Good afternoon. Today we're going to continue talking about graphing factored polynomials. And what you should notice in our first example here, or really the second example, is that our function is actually not in factored form. And so what we really need to be able to do is get it in that factored form, because it really gives us a lot of information about the graph, about various parts of it, some characteristics, and that's what we're trying to analyze. So the textbook is really nice, and they say use the fact that x minus 4 is a factor of the polynomial to help you factor it. And we know that sort of the factor is equivalent to the dividend divided by the divisor is another factor, right? So here we go. Review reverse box method. It's really nice if you already know that it's a factor and you're just trying to find the second factor. The remainder is 0, so we don't have to worry about that aspect of things. And so in the top left-hand box, we're going to put x cubed, and then we're going to ask ourselves what multiplies by x to get x cubed, which is x squared. So minus 4x squared. We need a grand total of 13 of them, so we need 9 more, which means 9x was multiplied by x. This gives me a positive 36x. I need 44 of them total, so I need to add 8 more. I know I must have multiplied x by 8, and then 8 times negative 4 is negative 32, which is equivalent to our constant, and that's sort of like one of our self-checks. And so now I know I can rewrite this in factored form. F of x is equal to x minus 4 times the quantity x squared minus 9x plus 8. Finally, I look at the last factor that I just calculated, and I would realize I can factor that again. So x minus 4, x minus 8, and x minus 1 would be a factored form of f of x. Part B says find the x-intercepts. So I know that if I take and I do 0 in for f of x, I can take x minus 4 times x minus 8 times x minus 1 and set each one of those equal to 0 because of the zero product property. And so x minus 4 is equal to 0, x minus 8 is equal to 0, and x minus 1 is equal to 0. So I get x equals 4 as the 0, or an x-intercept, x equals 8, and x equals 1. Great. So we have a lot of information already from the equation in its original form, and then the equation in factored form. We have zeros. We can actually identify our y-intercept from standard form. And then you come up with this really quite interesting question. It says, at which x values can the function change from being positive to negative, or from negative to positive? And so you might kind of set yourself apart and think about this for a second on a number line. And if I were just to start off with some positive numbers, where do I have to go to become negative? And the negatives are over here on the left. What splits them is 0. And I don't ever really become negative until after I've crossed over that 0. And we need to remind ourselves that 0 is neither positive nor negative. You can kind of think it as neutral. And so if I'm asking which x values can the function change from being positive to negative, or thinking the other direction, negative to positives, in each case I first have to cross over a 0. We just happened to calculate the zeros just a second ago, so my zeros are x equals 1, x equals 4, and x equals 8. So I can't cross over from positive to negative or negative to positives until I've met these x values. And so to sketch a graph of f, we need to consider whether the function is positive or negative on the 4 intervals. Why is that? Well, each interval is going to be either positive or negative, because at the values x equals 1, x equals 4, and x equals 8, we know that each of these would be the zeros. So how can we tell if the function is positive or negative on an interval between the x-intercepts? And what we have to do is we pick a value in the interval and test, which really is evaluate, whether it is positive or negative. And once I pick one value in that interval, all the other values have to be positive or negative, because if I were to switch, I would have another 0. So if we look at the interval x is less than 1, is the graph above, which would make it a positive, or below, which would make it negative, the x-axis? How can you tell? And again, so I would choose something like x equals 0. I want to make this as easy as possible on myself, and I'd say f of x, so f of 0 is equal to 0 cubed minus 13 times 0 squared plus 44 times 0 minus 32. And this would be 0 minus 0 plus 0 minus 32 is negative 32, which is negative. Now you might be wondering, well, what happens if I picked like a half or a quarter or even a negative number like -8 or a -10? If we were to change to a positive value over this interval, we'd have another 0 at that spot. So we know, because we don't have any other zeros, that this whole entire interval must be below the x-axis when the interval changes from negative to positive. We would have another 0. And so it kind of all goes back to the discussion we had above, but our zeros are x equals 1, x equals 4, and x equals 8, so I don't have to worry about it until I get near 1, which is our next interval. Our next interval says for 1 less than x less than 4 is the graph above or below the x-axis, and how can you tell? So I'd pick a value such as, like, I want to make this as easy as possible, x equals 2, just above 1. 2's are pretty easy numbers to work with. I'd look at f of 2 equals 2 cubed minus 13 times 2 squared plus 44 times 2 minus 32. I'm going to let you guys practice order of operations, and I'm going to simply give you the evaluative value, which is 12, which is positive. And so is it above or below? Well, it is above the x-axis because x equals 2 is in the interval and positive. And so we kind of go back and forth. And so if you're looking at this between 4 and 8, is the graph above or below? And you could pick 5, and I'm going to let you check that out yourself. But the reality is the graph is below the x-axis because the value in the interval evaluated less than 0. That's another way to kind of think about it. And finally, for x greater than 8, the value is going to be positive. So again, one value you might check would be x equals 10. When you evaluate f of 10, you're going to realize that this is a positive value. And so what they're asking us to do is generate a sketch. So really carefully, a sketch is exactly what it sounds like. It's not completely accurate, but it does give us a lot of information about the graph. And so if I'm thinking about my zeros, I've got this axis here. And I can label this. You can skip count, but we should probably check to make sure it fits. 1, 2, 3, 4, 5, 6, 7, 8. So not really. We're just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so the zeros kind of indicate to me, well, one was at 1, another one was at 4, and the final one was at 8. And so in this whole interval, from all those negative numbers up to just really 1, it's going to be a negative value. So you have this graph, comes up, and then it bridges over into the positives, but it has to come back down because we have another 0. And then it's negatives. So this interval would be blue, it's positive. And then we bridge down into the negatives again. And then for the rest of the number line, or all the inputs, it's going to be positive again. So this is our graph. It's just a sketch. Put your arrows indicating it's going to keep going on and on and on. And it's not entirely accurate, so notice I didn't label anything but the x-axis where I was graphing. I didn't put any values in the y. I wanted to make sure that it was really just literally a sketch. Okay, and last thing you would want to do is just check it with Desmos. Check it with Desmos so that you can kind of look at these intervals and how accurate is your graph to the sketch itself. So this can be utilized with Desmos or a graphing calculator. So please summarize. Make sure you understand what happens when we have a 0 and how it can impact your graph. Not always do you end up with this nice alternating result where it's negative, positive, negative, positive. If at any point you have what we call a double root, okay, it's going to have a 0, but it would be positive on both sides of that 0, and that would be an indication that you had a double root. But we'll get into more scenarios later in the class. Thank you for your time.